Module 2, Spillage Management, Prevention, Control, and Response. 1. Introduction to Spill Prevention and Control. Spills are unplanned releases of substances, often liquids, but sometimes powders or gases, into the environment. They can occur in industrial plants, during transportation, at storage facilities, or even in residential settings. Why spills matter? Even small spills of hazardous materials can contaminate soil, groundwater, or surface water. Spills may cause fires, explosions, or health hazards. Cleanup costs can be enormous, and legal penalties can be severe. Spill prevention is always more cost-effective and environmentally friendly than cleanup. Prevention focuses on eliminating causes before they happen, while control is about limiting damage once a spill occurs. 2. Understanding hazardous substances. Before managing a spill, you must understand the materials involved. Not all spills are equally dangerous. A spilled bucket of water is inconvenient, but a spilled container of concentrated acid is hazardous. Categories of hazardous substances. Flammable liquids, e.g., gasoline, solvents, can ignite easily. Corrosive substances, e.g., acids, alkalis, can damage skin, metals, and materials. Toxic substances, e.g., pesticides, mercury, can harm living organisms even in small doses. Reactive substances, e.g., sodium, peroxides, can react violently with air, water, or other chemicals. Radioactive materials emit harmful radiation. Routes of exposure. Inhalation, breathing in vapors, fumes, or dust. Ingestion, swallowing contaminated food, water, or particles. Skin contact, absorption through the skin. Injection, entry through cuts or punctures. 3. Spill prevention strategies. 3.1 Facility design and engineering controls. Good design is the first line of defense. Secondary containment, dikes, dams, or trays to catch leaks. Double-walled tanks reduce the risk of leaks. Proper ventilation prevents accumulation of vapors. Automatic shut-off valves stop flow during abnormal conditions. 3.2 Storage practices. Store incompatible chemicals separately. Use sealed containers with clear labels. Avoid overfilling tanks and drums. Keep containers in cool, dry, well-ventilated areas. 3.3 Operational procedures. Standard operating procedures, SOPs, for handling materials. Regular inspections and maintenance. Employee training in safe handling. 4. Spill planning. Spill planning ensures everyone knows what to do before an incident occurs. 4.1 Spill prevention, control, and countermeasure SPCC plans. SPCC plans are legally required in many jurisdictions for facilities storing large amounts of oil or hazardous materials. They outline potential spill sources, preventive measures, containment and cleanup procedures, roles and responsibilities. 4.2 Risk assessment in planning. Risk assessment identifies likelihood of different spill scenarios, potential consequences, environmental, financial, legal. Response priorities, protect life first, then environment, then property. 4.3 Equipment readiness. Spill kits, absorbents, neutralizers, PP. Fire extinguishers. Emergency communication systems. 5. Managing a spill, the response process. A quick, organized response can make the difference between a small incident and a major disaster. Step 1. Assess the situation. What substance is spilled? How much has spilled? Is there an immediate threat to people or the environment? Step 2. Ensure safety. Evacuate if necessary. Wear appropriate PPE. Eliminate ignition sources for flammable spills. Step 3. Contain the spill. Use absorbent pads, booms, or sandbags to prevent spread. Close valves or plug leaks if safe to do so. Step 4. Stop the source. Shut off pumps. Upright tipped containers. Close ruptured lines. Step 5. Clean up. Use absorbents for liquids. Neutralize assets or bases if trained to do so. Collect contaminated materials for safe disposal. Step 6. Report and document. Notify relevant authorities if required. Document cause, response, and lessons learned. 6. Spill containment methods. 6.1 Physical containment. Booms, floating barriers for oil spills in water. Dikes and berms, earthen or concrete barriers on land. Drip pans, catch leaks during maintenance. 6.2 Absorption. Absorbent pads, mats, granules, or pillows made of cellulose, polypropylene, or clay. 6.3 Neutralization. Acids can be neutralized with alkaline materials, e.g., sodium bicarbonate. Bases can be neutralized with weak acids, e.g., vinegar. 7. Spill management in different environments. 7.1 Land spills. Immediate diking to prevent spread. Excavation of contaminated soil. 7.2 Water spills. Deploy floating booms to limit spread. Skimmers to remove oil. Dispersants to break oil into smaller droplets, with caution. 7.3 Indoor spills. Ventilate to remove fumes. Avoid washing chemicals into drains unless safe. 8. Special considerations for hazardous spills. Hazardous spills require extra caution. Chemical identification before cleanup. Specialized PPE, respirators, chemical-resistant suits. Decontamination procedures for personnel and equipment. Coordination with fire department and hazardous materials, hazmat, teams. 9. Spill training and drills. Training ensures employees can respond confidently. Classroom instruction on hazard and response procedures. Hands-on training with spill kits and containment devices. Regular drills to test readiness. 10. Post-spill evaluation and improvement. After cleanup, it's essential to evaluate. What caused the spill? Was the response timely and effective? What equipment or training could be improved? Post-spill reviews prevent recurrence and improve safety culture. 11. Spill case studies. Case 1. Industrial oil spill in a river. Cause: faulty valve in transfer pipeline. Response: immediate deployment of booms, skimmers, and vacuum trucks. Lesson: regular valve inspection could have prevented the incident. Case 2. Laboratory acid spill. Cause: container dropped during transport. Response: evacuation, ventilation, neutralization with sodium bicarbonate, and safe disposal. Lesson: better container handling and use of secondary containment trays during transport. 12. The link between waste management and spill management. Waste management and spill management are interconnected. Poor storage of waste can lead to spills. Spills can create large amounts of contaminated waste. Both require preventive planning, training, and compliance with environmental laws. Summary of Module 2. We have covered spill prevention, hazardous substance handling, planning, emergency response, containment methods, special hazard considerations, and post-spill evaluation. Together with Module 1, you now have a full understanding of modern waste and spillage management from both the strategic and operational perspectives.